All right, this is going to be first introductory lesson to differential equations. So what we're going to cover in this lesson, I'm going to cover what a differential equation is. Helps to start with. What the order of a differential equation is, what the solution to a differential equation is, what an initial value problem is, and how to solve both differential equations and initial value problems. And really, we're just going to be, for this part, we're just going to be looking at some pretty easy cases, things actually we already know how to do. All right, we'll talk about harder cases in later lessons. Okay, so move this out of the way. What is a differential equation? Well, its differential equation is just an equation that has a derivative in it, any derivative in it. We're used to seeing these, and we're used to seeing them usually in something like this, a fairly straightforward explicit form where we've got f prime of x equals x squared plus 4, or we have it write it different ways, dy dx equals whatever, y prime. There's different ways of just writing the derivative. We'll see much more complicated and interesting ones later on, but I wanted to start with this. This is familiar to us. Okay, so these are would all be examples of differential equations. The order of a differential equation, every differential equation has an order, and that's just the degree of the highest derivative that occurs in the function. So for example, familiar one here, dy dx equals 2x minus 5. That would be a first order differential equation because dy dx is the first derivative of the function y. On the other hand, if we had something like this, f double prime of x equals cosine x plus 2, that'd be a second order differential equation because there's a second order derivative in the function, the second derivative of the function f of x. All right, pretty straightforward. Okay, solving a differential equation. Solving a differential equation just means finding the equation or equations whose derivatives satisfy the equation. So we're going to find an equation that has, basically, if we want to solve this differential equation, f prime of x equals 2x plus 4, we want to find the function f. We want to find f such that f prime is 2x plus 4. Okay, so we know how to do this, right? We know that f of x is going to be the antiderivative or indefinite integral of f prime of x dx. So it's going to be the antiderivative or indefinite integral of 2x plus 4 dx. And that's a pretty straightforward problem. That's going to be x squared plus 4x. And remember, plus c, plus our constant of integration. This becomes important, and this is going to be really this c thing that we've been adding on for a while and just kind of doing that as a matter of habit. It's important, and we'll see why now, because what we get from this, solving this differential equation, is not one equation, but one solution, but a general solution. It's called a general solution because the solution, x squared plus 4x plus c, represents a family of functions, each that have different constants of integration. Okay? So there's a whole bunch of different functions, x squared plus 4x plus 5, x squared plus 4x minus negative 13, or whatever. A bunch of different functions represented by that family. Okay. Second kind of problem we're going to look at is called an initial value problem. An initial value problem consists of a differential equation and an initial condition or initial value. That is the value of the higher order function, the function that we're looking for, at some point. The function that's the solution, right? So a solution to an initial value problem is going to be some particular equation that satisfies both the differential equation and the initial value. So for example, we might get something like this. Find the solution to the differential equation f prime of x equals 4x minus 7 such that f of 1 equals 5. Well, we know how to find f of x, right? And we've done this kind of thing before, just under a different name. We know f of x is going to be the antiderivative, or indefinite integral of f prime of x. So it's going to be the antiderivative of 4x minus 7 dx, which is going to be what? 2x squared minus 7x plus c. Okay, right now we have a general solution. We've got a family of functions picked out by 2x squared minus 7x plus c. We're looking for the one where f of 1 equals 5, right? We're looking for the one that meets that condition. So f of 1 is going to be what? 2 times 1 minus 7 times 1 plus c. And we said that should equal 5. Well, we do the algebra here. We got 2 minus 7, that's negative 5. Add 5 both sides, so we're going to get c equals 10. So we end up with this solution, and this is going to be our particular solution to the initial value problem. It's going to be 2x squared minus 7x plus 10. And I know we've done this. We've done this under a different name. Things will get much more complicated later on, but to start with, this is just the same basic idea we've been working on. This is called finding a particular solution to the differential equation. It's the same thing as solving an initial value problem. We're finding one equation, not the family of equations, but one function that satisfies this differential equation. All right. So why don't you pause the video here, just try out this problem here. It's going to say, it says find the solution to the differential equation f prime of x equals cosine 2x such that f of 0 equals 6. So pause here, do the problem real quick, and then come back and check the solution. Okay, so we know again that f of x equals the antiderivative of f prime of x dx. So it's going to be the antiderivative of cosine 2x dx. And you can do some substitution here. You would substitute u equals 2x, but I'm going to kind of skip ahead and just go straight to the heart of it, which is you're going to get 1/2 sine 2x plus c, plus the constant of integration. So here's f of x. Again, now we have the general solution. We have a family of functions, f of x. We want the particular one, and the particular one that satisfies this condition. So we're going to say f of 0 equals 1/2 sine 2 times 0 plus c, and we say that equals, we're told here that equals 6. Well, sine of 0 is 0, so this whole thing becomes 0, and we just end up with c equals 6. All right, so here's our final answer. Our particular solution here, the solution to this initial value problem, is going to be f of x equals 1/2 sine 2x plus 6. And that's it. So that's all there is to it for now, right? That's what differential equations are now. We'll look at some more complicated things in a minute.